Guys, so now we are going to learn about for loops in Java. Let's start a project. We'll call it for loops. Again, if any of this doesn't look familiar, please go back to the start of the playlist. Make sure you've installed everything properly. So we're in IntelliJ, we'll press create. Now we will get this window here. And we're going to go in this main method, get rid of everything, and we'll start doing some for loops. So first I'm going to write a comment here just to describe what we're doing. So, a for loop, what is that, you may ask, unless you've watched the previous video in this series where we featured some for loops. So I'd recommend going and watching that beforehand, but now we're actually going to learn about how these work. So a for loop is like a track for running laps. You sort of decide the amount of iterations you want to run before you start. And the for loop represents a block of code that runs that many times, if that makes sense. So it's a way that you perform repetitive tasks in code. So for example, let's say a for loop for saying hello, right? Now, here's what we do in Java to create a for loop. For, and then we want a counter, right? So we want to do this n amount of times. But we want to keep track of what we're doing and the current bit we're on. So let's say, we're on our first round, our second round, our third round, almost like laps, if you will. So we create an integer inside here called I. Now, it doesn't have to be called I, we can call it whatever you want, but in lots of different programming languages and in lots of different scenarios, you will see the word I being used. Right? We create our counter inside here. Now, obviously, this starts at 0. We can have it start at any number, 1, 2, 3, 4, but we'll start at 1. And then we want to repeat this 1 through 5, which is going to be 4 times. Because obviously we don't include the 5th one, unless we want to include the 5th one, which we can do. So if we want to go 1 through 5 times, we go greater than or equal to 5. And then we want to go I++. Now all this does is it says increment I by 1 every time we run a lap. Right? So we want our curly brace there, press enter, and then everything in here will be executed each and every time until the counter is less than or equal to 5. So let's print running lap and then I, not 1, I. Okay, so let's see what this outputs. So as we can see, this code gets repeated many times without us having to write it manually. So we run lap 1, lap 2, lap 3, lap 4, lap 5. And the reason why lap 5 is the last one is because 5 is not less than or equal to 5. Therefore, we stop. So just to go over this again, right? So in I equals 1, it's like we're starting at lap 1. And this is used as a counter. So the condition I is less than or equal to 5 checks if we still have more laps to run. And also, it means that, keep running until you complete 5 laps. Now, if we change this to just, less than, then we would end up running 4 laps. Like this. 4 laps. Because when we get to 5, because we start at 1, when we get to 5, 5 is not less than 5. Now, this is why usually we'll start at 0 instead of 1. So now we go from 0 to 5, which is 5 times. So we run that. If we run that here, I was meant to run that using just a standard run. We then have 5 laps, but obviously we start at lap 0, right? So just to symbolize that, this is the first lap, second lap, third lap, fourth lap, technically speaking, we can't run the 0th lap. So I always do I plus 1. Oh, we need to put this in brackets. Let's run that again. So now we have 1, 2, 3, 4, 5. And that is how a for loop works. Now, think of it like this. Let's give another example that's not running laps. So let's say we are a bakery, right? So I'm a bakery and I, cook, I bake, I make things. Let's say I bake, a cookie, right? I offer cookies in my bakery. They'll create those in batches, right? So I might have multiple batches of cookies so that I can create these en masse, a lot of them. So let's say we bake 4 batches of cookies, right? That means we want to repeat the steps it would take to create 1 batch of cookies but 4 times. So 4 times over. And it's the same process every time, one batch does not vary from the other because they're all sort of the same sort of cookies, right? Now, for each time we might put a batch in the oven, we would count that as 1 iteration. So for example, let's say we could say for int I equals 0, I is less than 4, I plus plus, curly bracket. We then want to, do something like put the cookies in the oven, right? And each time when we put the cookies in the oven, or when we, create the cookies, right? So let's, create the cookies, put the cookies in the oven. That process is going to be the same every single iteration. Therefore, we don't have to repeat this code many, many times. We could just have it in here once and then have Java repeat the code for us. So let's go system out, mixing the ingredients to create a cookie. Well, to create the batch of cookies. Now, obviously, we can customize this. We could say you could say create batch hashtag, I don't know, I of cookies. Now, obviously, that will output batch 0, batch 1, batch 2, batch 3. But obviously, we don't want to have it as batch 0 because as humans, we start counting from 1 rather than 0. So I'm going to say I plus 1, like this, just so it's more readable. It's the same batch, but it's, just a human readable format. Then we can copy this and say, I'm putting this batch of cookies in the oven. So we could say putting batch, whatever the batch number is, of cookies into the oven. Now, if we run this, we'll see mixing the ingredients to create batch 1, and I've just noticed we need a space, so let's go ahead and fix that. Because obviously the 1 and of cookies was together. We want to do the same thing here. Let's run again. Mixing the ingredients to create batch 1, putting batch 1 of cookies into the oven, mixing the ingredients batch 2, etc., etc., etc. That code is repeated many times, and we've only put it in once here. And we could even scale this up. Let's say we wanted 10 batches of cookies. We could have it do 10 batches of cookies and we're only doing this in code once. We could have 100 batches of cookies and it will run. And we have all these runs of that for loop, and we've only written this tiny bit of code here. So without the for loop, we'd have to do these all manually. We could say 1,000. Right, and now we can see that this is getting quite long, right? We can notice some lag here. And obviously, the more zeros we add to this, the longer the program is going to take to run. And obviously, the more batches we have, the longer it will take for us to cook, right? Because, we have to do stuff over and over again. Now, obviously, computers are pretty fast, so it does it fairly quickly. But if we scroll up, that's quite a lot of batches. Now, obviously, computers do things instantly. Now, this runs at near instant, but not quite instant. The more zeros we add to this, the longer this program is going to take to run. So if we add more zeros and then make it like 5, and then press run, we'll start to see it still running. So that's taking quite a few seconds. Still going, still going, still going. And obviously, it's carrying on, but at some point it will stop, right? And we could wait around for a fair amount of time to wait for all of these batches to cook. And obviously, in this scenario, it's taking like a millisecond to cook these cookies and make the cookie dough as well. But point being is that these for loops can do things repeatedly, but the cost of that is time. So it takes, the more iterations we have, the more time it's going to take, because it does it one after the other, after the other, after the other, and you can see that with the numbers here. We could wait for this to complete, or we could stop the program. So how do we stop the program? We go up to this red thing here, which says stop main, and we click. And as you can see, we finished on batch 34665912, which is nowhere near the amount of batches that we wanted to complete. So let's scale this down a bit. Let's say we want 10 batches, right? Now, this would run obviously 10 times. Now, essentially, this is instant, like I said. But the issue is, I want to be able to represent this sort of being slower, like in real time, right? So what we can basically do is, this is a more advanced sort of feature, right? But we can go time unit dot seconds dot sleep. If you copy this down, and then what we can do is this takes in a long, which can be a big number if we wanted. Let's say I want each batch to take 20 seconds, right? We could essentially have it wait 2 seconds every single time we iterate. And as you can see here, there's some red here, and it says unhandled exception, interrupted exception. Let's just press add exception to method signature. Now you might not have noticed a change, but if we scroll up, this has changed here. We're going to cover exceptions later on in this series, but let's just not worry about this for now. We just want this to be able to run. We're trying to demonstrate for loops. And that the trade-off with for loops is that it takes time. So now, as we see, we can basically watch it cook the batches. So now each batch is going to take, 20 seconds. So we're going to have to wait 20 seconds for each of these. So now it's not going to be so instant. So the computer's going to take 20 seconds to sort of manufacture these cookies. So let's wait 20 seconds. We'll only wait for this. Yeah, there we go. So we've got the second one. We could wait for all 10, but that would be a waste of time. So what we're going to do is just press this stop button here. Cool. And let's just get rid of this time unit stuff, and let's just get rid of this throws interrupted exception here, because we're going to go over that later. Right, so hopefully you understand for loops and the trade-offs and how to write a for loop in Java. But the issue is that we basically have to define this maximum, batches that we want to create in advance. We have to put that in here. What I showed you guys in the last module with arrays was that we can have the upper bound of this be the length of an array. So for example, if we wanted an int array, right, we could say array of 10. We could go equals and then curly brackets and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which obviously this is a length of 10, which is the same here, but let's just create an 11th and a 12th. We can put spaces after these commas, but it doesn't matter. You can, if you want to. It doesn't affect anything about the program. This is better for readability. And then here, what we can do is instead of hard coding it as 10 here, we can make it the length of an array. How do we do that? We type a reference to the array variable, then dot, and then length. So this is going to dynamically get us the length of this. So at the moment, the length of this is 12. So then what's going to end up happening is we then cook 12 batches, as we can see here. If we added another element to this array, comma 13, we will end up cooking 13 batches. Now obviously we got rid of the waiting because we want this to happen instantly, but obviously the bigger this array gets, the more time it will take to run. So this is how you do iteration in Java. There's many use cases for iteration, one of which is searching an array, one of which is sort of sequentially going over an array. You'll see these loads in Java, but this is the most basic form of a for loop. Tune in next for while loops. See you guys.